Hello there, and welcome to the Sleepy Science Channel. I'm so glad you found your way here tonight. Maybe it's been a long day, or maybe you're someone who likes to drift to sleep with quiet wonder, letting thoughts of distant worlds replace the noise of daily life. There's nothing you need to do now but rest. Let your mind grow still, your breathing slow, and your body light. Because tonight, we're not just closing our eyes. We're traveling toward one of the most extraordinary realms in the cosmos. From the soft glow of distant galaxies to the deep, quiet heart of a colossal cluster, we'll explore Phoenix A, a supermassive black hole whose astonishing hunger shapes an entire region of space. We'll wander gently from the origins of the cluster to the vast oceans of hot gas around it, and finally into the calm gravitational embrace of the black hole itself, with 100 sleepy facts to ease you into rest. And if these calm explorations help you drift off, consider liking and subscribing. It helps other sleepy travelers find their way here too. Now, close your eyes and let's begin. Fact 1. A cluster in the quiet dark. Long before our instruments ever sensed its glow, the Phoenix cluster drifted in silence far across the universe. It lives more than 5 billion light years away, so distant that the light reaching us tonight began its journey before Earth even formed its first mountains. In that quiet region of space, hundreds of galaxies gather together like softly burning embers in a cosmic hearth. The cluster rests in the southern sky, hidden behind faint constellations until powerful telescopes coaxed its presence into view. What we see now is a realm of great mass and even greater calm, where galaxies drift slowly through an ocean of hot, glowing gas. And deep at its heart, something even more extraordinary waits for us to notice it. A darkness shaping everything around it. Fact 2. Light from 6 billion years ago. When we study the Phoenix cluster, we aren't seeing it as it is. We're seeing it as it once was. Its light has been traveling toward us for roughly 6 billion years, crossing a universe that has stretched and cooled in the time since it first set out. What reaches our telescopes is ancient starlight, softened by unimaginable distance, as if arriving through a mist of time. Every photon carries a memory: the temperature of the gas, the shape of a galaxy, the whisper of a star being born. It is a gentle time capsule drifting across cosmic oceans, arriving quietly on Earth. And within that ancient glow lies a clue to something far brighter and more powerful hiding at the cluster's center. Fact 3. A name born from heat. Astronomers named the Phoenix cluster, not because of mythology, but because of the way it blazes in X-ray light. The cluster shines intensely in wavelengths our eyes cannot see, glowing with the heat of gas tens of millions of degrees hot. That brilliant radiation inspired the name, a cosmic phoenix rising in luminous fire. Yet this fire is not chaotic or violent. It is steady, warm, and expansive. It wraps the central galaxy in a soft halo, illuminating threads of cooling gas as they drift inward like glowing ribbons. From this brightness emerges a story of creation and collapse, of heat and cooling, of balance and imbalance. And at the center of that glowing nest, the black hole known as Phoenix A waits with quiet gravity. Fact 4. The moment of discovery. The Phoenix cluster first revealed itself not with a burst of drama, but with a quiet shimmer of data. Astronomers studying the sky through powerful space telescopes noticed an unusually bright patch of X-ray light, brighter than most clusters they had ever measured. At first, it seemed almost too luminous to be real. as though the universe had painted a small flame into the darkness. Careful observations confirmed it. A remarkably active, cooling, star-forming cluster, unlike nearly any other known. Each telescope, Chandra, XMM Newton, and later others, added soft brushstrokes to the picture. By the time the discovery was official, scientists realized they had stumbled upon a cosmic overachiever glowing steadily across billions of years. And deep within that brightness, something immense was shaping the story. Fact 5. A rare cosmic overachiever. Most galaxy clusters exist in a sort of quiet equilibrium. Their gas stays hot, their galaxies age slowly, and nothing changes very quickly. But the Phoenix cluster is different, as though it decided to shine a little brighter, cool a little faster, and form stars a little more enthusiastically than its cosmic cousins. Its central galaxy forms new stars at an astonishing pace, far more rapidly than typical cluster cores. The surrounding gas seems to cool with unusual efficiency, drifting inward like slow rain falling toward a valley floor. Even the cluster's X-ray glow is exceptional, brighter than nearly any other known cluster at its distance. This rare intensity makes Phoenix a unique cosmic laboratory, a place where balance wavers and extraordinary processes unfold. And at the middle of that imbalance lies the black hole that anchors it all. Fact 6. A river of X-ray light. When telescopes look at the Phoenix cluster in X-ray wavelengths, they see a soft, luminous river of light flowing across millions of light years. This glow isn't produced by stars, but by gas heated to tens of millions of degrees, so hot that atoms themselves tremble and shine with high-energy radiation. The light spreads through the cluster like a warm fog, revealing cavities, waves, and subtle patterns carved by the central black hole's ancient activity. Even from so far away, the X-rays arrive gently, whispering information about temperature, pressure, and movement inside the cluster's enormous atmosphere. Through that shimmering river, astronomers can trace the slow pulse of Phoenix A, the dark heart that stirs the surrounding gas. And with each new detail revealed, we drift one step closer to meeting the black hole at its core. Fact 7. A cooling giant. Unlike most galaxy clusters, which hold on to their heat stubbornly for billions of years, the Phoenix cluster cools at an unusually fast pace. The gas filling its vast interior begins incredibly hot, but gradually loses energy, radiating away warmth like a giant cosmic ember slowly fading. In many clusters, black hole activity prevents this cooling from going too far. Yet here, the cooling flows are stronger, more persistent, as though the cluster itself is exhaling softly into the dark. This cooling gas drifts inward toward the central galaxy, forming thin filaments and gentle currents that slide through the hot medium. It is one of the reasons Phoenix is so luminous. Cooling gas shines brightly as it sheds energy. And all that drifting material begins a journey towards something far more powerful at the cluster's core. Fact 8. Stars born in the deep. The rapid cooling of the Phoenix cluster gives rise to something rare, a galaxy in the center that is still brimming with new stars. While many cluster cores are calm and quiet, the Phoenix brightest cluster galaxy is active, vibrant, and unexpectedly youthful at heart. Hundreds of stars ignite each year, tiny furnaces glowing in regions where gas gathers and condenses. These newborn stars emerge from long, cold streams of gas that settle into the galaxy like gentle snowfall. Some form in clusters. Others drift alone. Their light blends into a soft, hazy glow that fills the central region, brightening the galaxy from within. It is a quiet storm of creation, fueled by the cluster's cooling flow. And this flourishing heart leads us closer to the dark giant guiding the rhythm of this cosmic ecosystem. Fact 9. A central galaxy out of balance. The central galaxy of the Phoenix cluster does not behave the way astronomers expect. It is both extremely bright and unusually active, as if caught between competing cosmic forces. The cooling gas pours inward so quickly that even the mighty black hole at the center cannot fully counteract it with its heating. This creates a delicate imbalance, a tug of war between cooling and energy release, between stillness and motion. In the soft, glowing center, filaments of cold gas extend like faint tendrils, weaving through the hot, intracluster medium. They reveal where the galaxy has gathered its raw material, feeding both star formation and the black hole that lies deeper within. And at the bottom of those drifting filaments, Phoenix A waits with patient gravity, shaping everything around it. Fact 10. The dark heart within. At the very center of the Phoenix cluster's brightest galaxy lies a presence so quiet it can be detected only through the light it disturbs. Phoenix A rests there, hidden within a cocoon of stars and drifting gas, shaping its surroundings through gravity alone. It does not shine, yet everything around it glows because of its influence. The filaments of cold gas, the heated caverns in the cluster's atmosphere, and the gentle stirrings of the central region. Though it remains unseen, its signature is unmistakable. The shape of the galaxy, the flow of cooling gas, and the bursts of star formation all point toward a single anchor, a supermassive black hole of extraordinary proportions. And now, our journey draws us gently toward its immense gravitational presence. Fact 11. Mass beyond imagination. Phoenix A is one of the most massive black holes known in the universe. Estimates suggest it may reach tens of billions of times the mass of our Sun, a weight so great that even nearby galaxies feel its gravitational pull. But mass does not translate to noise or fury. Instead, Phoenix A sits at the center like a silent mountain, influencing everything without ever revealing itself directly. Its mass compresses space around it, creating a deep gravitational well where matter spirals inward in long, graceful arcs. Stars near the core move more swiftly. Gas clouds stretch and soften as they fall toward the center. Yet from afar, all of this motion appears serene, folded into the stillness of the galaxy's glow. And at the edge of this gravitational basin lies a boundary unlike any other in nature. Fact 12. A boundary of no return. Every black hole has an event horizon, a quiet surface that marks the threshold beyond which nothing can escape. For Phoenix A, this boundary is enormous, extending far beyond the orbit of our entire solar system. It is not a wall, nor a solid edge, but a region where gravity deepens so gradually that an infalling traveler might feel nothing at all while crossing it. Outside the event horizon, gas swirls in a luminous dance, heating as it approaches its final path inward. Inside, the physics we understand falls silent, replaced by mysteries we can only imagine. Yet despite its enormity, the event horizon does not roar or flash. It stands in perfect stillness, defining where light itself must surrender. And around this silent border, the galaxy continues to drift and glow, guiding us deeper into the heart of Phoenix A's story. Fact 13. A calm center of storms. Despite its unimaginable mass, Phoenix A does not rage or thunder. Instead, it sits in a region that appears almost strangely tranquil. Gas spirals toward it in broad, gentle arcs. Stars drift quietly past. their motions shaped by the black hole's steady pull. From a distance, the core feels like the calm eye of a cosmic storm, a place where the frantic energy of cooling gas and newborn stars softens into stillness. This serenity is deceiving because beneath it lies a powerful engine converting falling matter into heat and light. But even this activity unfolds in a slow, continuous rhythm rather than sharp bursts. Phoenix A's influence radiates outward in waves, subtle yet persistent. And beyond this calm center, the galaxy's streams of drifting gas begin their long descent inward. Fact 14. The feast of hot gas fuel for Phoenix. It comes not from a violent collision or a sudden influx, but from the quiet rain of hot gas cooling within the cluster. As the surrounding atmosphere loses energy, it sinks toward the core, forming long, delicate filaments that stretch like soft ribbons across space. These filaments deliver material slowly, steadily, feeding the black hole over millions of years. When this gas nears the event horizon, it heats rapidly, glowing brightly in X-ray wavelengths. But the process is surprisingly ordered. The gas doesn't crash inward so much as drift, settling into spiraling paths before crossing the point of no return. Every atom that falls into Phoenix A contributes a tiny spark of radiation that helps illuminate the cluster. And this gentle, unending feast fuels something even more remarkable: the black hole's quiet radiance. Fact 15. Bright. Despite the darkness, though Phoenix A itself emits no light, the space around it shines vividly. As gas falls inward and accelerates, it heats to astonishing temperatures, glowing in X-rays and ultraviolet light. This surrounding brilliance, the accretion disk, reveals the black hole's presence like a lantern glowing behind a veil. The brighter the disk, the more actively the black hole is feeding. In Phoenix A, this glow is especially intense, shining across billions of light years to reach our telescopes. Yet even with all this luminosity, the process remains smooth and graceful. There are no bursts, no flares, no harsh disruptions, only a continuous, slow spiral of matter, warming as it drifts inward. And from this warm glow, energy flows outward into the cluster, ready to shape the gas that surrounds it. Fact 16. A fountain of energy. Even though Phoenix A sits in darkness, the energy it releases flows outward like a slow, steady fountain. As gas spirals inward, part of its mass transforms into radiant heat, sending ripples of warmth through the galaxy's core. This energy rises in soft waves, spreading into the surrounding atmosphere and subtly changing the temperature of the cluster's vast reservoir of gas. Unlike explosive outbursts seen in some active galaxies, Phoenix A's energy release seems almost meditative, a continuous, gentle exhalation rather than a sudden roar. The black hole heats its environment not through violence, but through endurance, warming the region across millions of years. And this warm breath of energy helps carve the paths of the delicate jets that extend far from the core. Fact 17. Jets that whisper across space. From the poles of Phoenix A, thin jets of charged particles stream outward into the surrounding gas. They travel enormous distances, yet their presence feels surprisingly subtle. Instead of blazing through space with fierce intensity, they move with quiet persistence, shaping the cluster's atmosphere like soft brushes painting faint lines across the dark. These jets are not loud or chaotic. They nudge the gas gently, creating channels and cavities that stretch across the hot intracluster medium. Their motion stirs the surrounding atmosphere just enough to keep it from settling too quickly, sending small ripples through the glowing sea of plasma. And where these jets meet resistance, something beautiful begins to form. Great, hollow spaces carved in the X-ray light. Fact 18. Ripples in the cosmic sea. As the jets from Phoenix, they push outward, they inflate vast cavities in the surrounding gas, buoyant bubbles rising like lanterns in the night. These hollow pockets are faint when viewed from Earth, but they reveal themselves in X-ray maps as soft, rounded shapes where the glow briefly dims. Around their edges, waves and ripples spread outward, carrying the echo of the black hole's activity. These ripples travel through the cluster as gentle fluctuations in temperature and pressure, like the faint hum of a distant vibration. They do not crash or break. They drift slowly, crossing tens of thousands of light years before fading into the warm plasma around them. And each ripple tells a story of energy released long ago, guiding us deeper into the delicate balance between heating and cooling that defines the Phoenix cluster. Fact 19. A balance of heating and cooling. The Phoenix cluster lives in a delicate equilibrium. As the black hole gently warms the surrounding gas, the cluster's atmosphere simultaneously cools, slowly radiating away heat like a vast cosmic ember. In most clusters, the black hole's energy keeps cooling in check. But here, the cooling flows are so strong that Phoenix A can only soften them, not fully stop them. This creates a serene, ongoing tension, a cosmic tug-of-war that never breaks into conflict. Instead, the two forces settle into a quiet partnership, each shaping the other over millions of years. The result is a core that glows with warm X-rays, threaded by cool ribbons of gas drifting inward. And as this balance continues, new structures emerge in the cluster's shimmering interior. Fact 20. The cluster's beating heart Phoenix. It acts like a slow, steady heart for the entire cluster. Its energy pulses outward in cycles that last far longer than any human history, warming the intracluster medium and guiding how the gas moves and cools. These pulses aren't loud or dramatic. They are soft breaths of heat, drifting through the cluster like faint tides. Every shock wave, every ripple, every warm cavity tells part of the story. The black hole doesn't simply sit in silence. It orchestrates the rhythm of the cluster, influencing how stars form, how gas collects, and even how galaxies drift in the central region. This heartbeat is subtle yet profound, shaping everything around it with a quiet constancy. And beyond that warm influence lies the vast reservoir of gas that fills the cluster like a glowing sea. Fact 21. A cloud, 30 million degrees wide, surrounding Phoenix. A is an immense cloud of plasma called the intracluster medium, a sea of hot, thin gas stretching across millions of light years. Despite its low density, this gas is heated to nearly 30 million degrees, glowing brightly in X-ray wavelengths. It is the radiant fog that gives the Phoenix cluster its shimmering appearance when viewed through powerful telescopes. Yet this hot cloud is not uniform. Some regions cool faster, softening into colder streams that drift inward toward the central galaxy. Others remain warm, stirred slightly by ancient shock waves or by the gentle touch of the black hole's jets. This glowing atmosphere forms the backdrop for everything happening within the cluster, a vast cosmic canvas painted in light and heat. And from this enormous cloud, the next chapter of Phoenix A's story begins to unfold. Fact 22. Cooling faster than most clusters. In many galaxy clusters, the hot gas lingers at extreme temperatures for billions of years, barely cooling at all. But the Phoenix cluster behaves differently. Here, the gas releases its heat at a remarkable pace, shedding energy like a warm breath fading into a cold night. This cooling is so efficient that it creates a continuous flow of material drifting inward toward the central galaxy. As the gas cools, it condenses into denser streams, forming delicate filaments that trace soft pathways across the cluster's interior. These pathways act like gentle rivers, carrying material toward the center and fueling star formation on a scale rarely seen in clusters. And from these cooling currents emerges something once thought nearly impossible in a modern universe. Fact 23. Cooling flows. Reborn astronomers once believed that cooling flows, vast streams of gas condensing and flowing into cluster cores, were only theoretical or heavily suppressed by black hole activity. But in the Phoenix cluster, cooling flows thrive. The gas condenses and moves inward so readily that it revives an old concept, showing that nature still allows such processes under the right conditions. These flows deliver not just warmth, but life-giving material to the central galaxy, enabling it to create stars at a rate hundreds of times greater than the Milky Way. The filaments of cold gas extend like faint, shimmering bridges between hot and cool regions, linking the cluster's atmosphere to its vibrant center. And along those bridges, the seeds of stars quietly gather and grow. Fact 24. A galaxy of newborn stars. At the heart of the Phoenix cluster lies a galaxy glowing with unexpected youth. Each year, it gives birth to hundreds of new stars, igniting in pockets where cold gas settles and thickens. This star formation is unusually vigorous for a cluster core, where galaxies typically rest in quiet old age. But here, the central galaxy shines with the soft radiance of countless newborn suns. These stars form in clusters, in filaments, and in hidden pockets buried deep within cooling gas. Their light mixes into the gentle haze around the galaxy, creating a warm inner glow that spreads softly through the center. It is a cosmic nursery, alive with slow, steady creation. And at the end of each filament, deeper than the star-forming clouds, the pull of Phoenix A continues to shape the flow of everything around it. Fact 25. Quiet threads of cold gas. Stretching across the central region of the Phoenix cluster are long, delicate threads of cold gas, some extending tens of thousands of light years through the warm glow of the intracluster medium. These filaments form when cooling gas condenses into narrow, graceful structures that hang like cosmic silk between pockets of hotter plasma. They drift slowly, held in place by magnetic fields and the soft pull of gravity. In visible light, they appear faint and ghost-like, barely brushing the darkness. Yet they carry the ingredients for new stars, guiding cool material toward the galaxy's core in long, quiet streams. Each filament is a bridge between extremes: the hot, bright atmosphere of the cluster and the cool, shadowed regions where stars take shape. And deep within these threads lies the flow that continues to nourish Phoenix A. Fact 26. The music of pressure waves. As Phoenix A releases energy, gentle pressure waves ripple outward through the cluster's atmosphere. These waves are similar to sound, though traveling through thin, hot plasma rather than air, and they move slowly across enormous distances. Astronomers see them as subtle, concentric patterns in X-ray images, like the faint rings formed when a pebble touches the surface of a still pond. These waves carry warmth, helping to distribute the black hole's energy into cooler regions of the cluster. They are neither violent nor abrupt. Instead, they move with patient rhythm, softening temperature differences and maintaining a sense of cosmic balance. If we could hear them, their hum would likely be impossibly low, a deep, soothing murmur beneath the roar of the universe. And through their quiet vibration, they help stabilize the gas surrounding the cluster's core. Fact 27. A surprising lack of turbulence. Despite all the cooling, the star formation, and the energy rising from the black hole, the interior of the Phoenix cluster is surprisingly calm. Astronomers expected storms of turbulence, swirling eddies of gas and chaotic mixing, but instead found a region that seems unusually smooth. Velocities are gentle, motions are steady, and the gas flows in orderly streams that drift rather than churn. This calmness is one of Phoenix's great mysteries. How can a cluster with such intense cooling and such a powerful black hole remain so serene? The answer likely lies in the balance of forces. Jets that heat without disrupting, cooling that flows without collapsing, and magnetic fields that guide without tangling. And this serene atmosphere allows the cooling to continue, carrying us closer to the heart of the cluster's imbalance. Fact 28. A black hole that falls behind. In most galaxy clusters, the central black hole releases enough energy to keep the surrounding gas hot, preventing it from cooling too quickly. But in the Phoenix cluster, the cooling outpaces the heating. Phoenix A, massive and powerful as it is, simply can't keep up with the rate at which the cluster's gas loses energy. It's as if the black hole is breathing steadily, but the cluster around it exhales faster than it can warm. This rare situation allows rivers of cool gas to reach the galaxy's core, feeding both star formation and the black hole itself. Instead of stabilizing the region, the feedback loop leans toward cooling, creating the delicate imbalance that makes Phoenix so distinct. And from this imbalance, something extraordinary begins to unfold deep within the cluster's bright interior. Fact 29. A rare overcooling event. The Phoenix cluster is one of the few places in the known universe where astronomers see what's called an overcooling event. This means the gas cools so efficiently that it condenses much faster than the black hole can reheat it. The result is a dramatic flow of material gathering in the central galaxy, forming stars at a rate that feels almost primordial, as if the galaxy were reliving an earlier, more active era of cosmic history. Overcooling reshapes the entire environment. Filaments grow longer, star-forming clouds multiply, and the central region brightens with the soft glow of young stars. Instead of quenching activity, the black hole's energy becomes part of a larger, slow dance that cannot fully halt the cooling flow. And from this renewed cycle of creation, the central galaxy becomes a quiet oasis of starbirth. Fact 30. A star-forming oasis. While most brightest cluster galaxies are ancient and quiet, the one at Phoenix's center is vibrant and alive. Hundreds of stars spark to life each year, illuminating the core with warm, youthful radiance. Cool gas settles into pockets where gravity gathers it gently, forming nurseries where new suns begin to shine. The entire galaxy seems to glow from within, its light softened by dust and drifting filaments. This oasis of star formation is rare in the modern universe, especially in such a massive cluster. It's a reminder that even in environments dominated by gravity and heat, creation can still thrive when conditions are just right. The galaxy becomes a cradle, calm, luminous, and nourished by the steady rain of cooling gas. And beyond this glowing sanctuary, the cluster continues to expand outward into the vast sea of galaxies and plasma. Fact 31. Jets like gentle beams. From the core of Phoenix A, long, slender jets of charged particles extend into the surrounding space. Though they travel at nearly the speed of light, their presence feels surprisingly calm when viewed from billions of light years away. They appear as faint beams, subtle strokes of energy that guide the gas rather than tear through it. These jets help shape the atmosphere around the black hole, carving pathways through the hot plasma and gently redistributing heat. Instead of roaring outward, the jets move with steady purpose, inflating bubbles and stirring the cluster in slow rhythms. Their influence is vast, touching regions far beyond the central galaxy. And where these beams meet the surrounding gas, wide hollows begin to form in the X-ray glow. Fact 32. Cavities in the X-ray glow. As Phoenix A's jets drift outward, they sculpt enormous cavities in the cluster's hot gas, hollow spaces where the X-ray light dims, marking the absence of glowing plasma. These cavities are like buoyant bubbles, rising through a warm sea, gently lifting and stretching the surrounding gas as they ascend. They testify to the long, slow activity of the black hole, showing where energy has been quietly released over millions of years. Astronomers study these cavities to understand the history of the cluster's heating. Their size and shape reveal how powerful the jets once were, how long they have been active, and how the gas responded to their subtle push. Even though the cavities are vast, their formation is remarkably gentle, avoiding shock or violence. And around these hollow shapes, the warming influence of Phoenix A spreads softly through the cluster. Fact 33. Energy that shapes galaxies. The energy released by Phoenix affects more than just the gas around it. It helps determine the fate of entire galaxies within the cluster. When the black hole warms the surrounding medium, it slows the inward drift of gas, changing how material collects in the central region. This, in turn, influences which galaxies can continue forming stars and which ones settle into quiet, ancient stillness. In Phoenix, this energy is strong enough to shape structures on scales larger than any single galaxy, yet soft enough to let cooling continue. It's a delicate interplay. Heat slows the flow, cooling speeds it up, and the cluster settles into a dynamic balance that evolves with time. Through this balance, Phoenix A becomes a subtle architect of the environment around it. And from this gentle architecture, the next stage of the cluster's story unfolds in ripples and warmth. Fact 34. Heating the cosmic atmosphere. As Phoenix, it releases energy. The surrounding gas warms in quiet, gradual waves. This heating isn't explosive or unruly. It spreads like a slow sunrise across the cluster's core, lifting the temperature of the plasma by small but meaningful amounts. The warmed gas expands slightly, pushing outward in soft, buoyant motions. These shifts help prevent the entire atmosphere from collapsing inward too quickly. The heat radiating from the black hole's activity gives the intracluster medium a sense of gentle buoyancy. Cold pockets rise and fall, warm regions drift outward, and the overall structure settles into a rhythm that can last millions of years. The cluster becomes a layered, breathing environment shaped by subtle gradients of warmth. And within this floating landscape, the struggle between cooling and heating continues its quiet dance. Fact 35. A delicate tug of war. Inside the Phoenix cluster, cooling and heating are locked in a long, graceful contest. Cooling gas tries to sink toward the center, gathering into narrow filaments and soft clouds. Heating from the black hole pushes outward, raising the temperature just enough to slow those flows, but not enough to stop them. The result is a cosmic balance so delicate that even a small change could shift the entire environment. This tug of war is not a battle, but a partnership. Each process shapes the other, creating a system where star formation, gas motion, and black hole activity all coexist. In many clusters, heating wins. In Phoenix, cooling remains surprisingly strong, giving the core its signature glow and its rare vitality. And in that balance, faint whispers of activity drift outward in the form of radio waves. Fact 36. The silence of radio waves. The jets and bubbles sculpted by Phoenix. They produce soft radio emissions that flow through space like nearly silent currents. These radio waves carry the imprint of charged particles spiraling along magnetic fields, generating signals that astronomers can detect even across billions of light years. Yet despite their immense distance, these waves feel gentle, a quiet hum stretching across cosmic time. Unlike the violent bursts seen in some active galaxies, Phoenix A's radio signature is subdued. It speaks of continuous activity rather than sudden flares, of jets that persist softly instead of tearing violently through the gas. The faintness of the radio glow adds to the cluster's serene atmosphere, painting Phoenix as a place of slow, steady processes. And from this quiet radio hum, astronomers trace the outlines of ancient cavities and long-past outbursts, leading us gently deeper into the cluster's history. Fact 37. Giant cavities older than stars. In the glowing heart of the Phoenix cluster, enormous cavities drift like ancient hollow lanterns. These vast bubbles, carved gently into the hot intracluster medium by Phoenix A's past activity, have existed for tens of millions of years. They rise slowly, buoyed upward through the shimmering gas, leaving behind faint trails and subtle distortions in the X-ray glow. Though they were formed by powerful jets long ago, the cavities now float in silence. Their edges are smooth, softened by time, and their interiors are filled with lower density plasma. They act as quiet records of the black hole's earlier breaths, gentle reminders that even in its calm present, the core once stirred more energetically. And as these bubbles rise, they reveal echoes of events that unfolded ages before our world ever formed. Fact 38. Echoes of ancient outbursts. Scattered throughout the Phoenix cluster are subtle marks of ancient eruptions, each one a faint echo of a time when Phoenix A fed more vigorously. These outbursts pushed waves of energy outward, leaving behind ripples, cavities, and gentle distortions still visible in the cluster's light. Though millions of years have passed, these imprints remain like soft fingerprints pressed into warm clay. Astronomers can read these features as a kind of cosmic diary. The size of a ripple hints at the strength of an outburst. The shape of a cavity reveals how the gas responded. The distance from the core tells how long ago the black hole last stirred deeply. Yet even the strongest of these echoes carry no sense of violence now, only the calm persistence of history stretching across deep time. And from these quiet signatures, we understand how Phoenix A's appetite has changed throughout the ages. Fact 39. The black hole's changing appetite. Phoenix A does not feed at a constant rate. Over millions of years, its hunger rises and falls like a slow tide. Sometimes it draws in more gas, brightening the core and sending stronger jets into the surrounding medium. Other times, its accretion quiets, and the glow around it softens into a gentle lull. These shifts shape the cluster's rhythm, guiding when cavities grow, when waves ripple, and when cooling flows gather strength. Today, Phoenix A appears to be in an intermediate state, neither fully dormant nor fiercely active. Its intake of gas is steady, its energy output gentle, its jets persistent but subdued. This changing appetite tells astronomers that black holes are not static monsters, but living engines with long drifting cycles. And this calm, balanced state sets the stage for the next chapter of the cluster's evolving story. Fact 40. A rare middle state. Many supermassive black holes swing between extremes, long stretches of quiet followed by bursts of intense activity. But Phoenix A appears to rest in a rare, gentle middle state. It feeds steadily, not too slowly and not too fast, maintaining a calm rhythm that neither dominates the cluster nor fades into silence. This quiet consistency gives the region around it a serene stability, allowing cooling flows and star formation to proceed without sudden disruption. In this middle state, the black hole becomes less like a fierce engine and more like a patient, steady furnace. Its jets glow softly, its accretion disk warms gently, and its energy spreads outward in smooth, continuous waves. And outside this calm, the wider cluster stretches into a great gathering of galaxies drifting together through the night. Fact 41. Galaxies like winter embers. The Phoenix cluster is home to hundreds of galaxies, each one glowing like a distant ember suspended in deep darkness. Some are bright ellipticals, round and smooth. Others are spirals with faint arms curling delicately through the void. Together, they orbit the cluster's center like slow-moving stars in a vast celestial dance, drawn by the immense pull of the cluster's mass. Although separated by millions of light years, the galaxies share the same gravitational home. Their motions are gentle and orderly, shaped by the invisible halo of dark matter that surrounds the cluster. As they drift, their combined light forms a soft, scattered glow, a quiet constellation contained within a single structure. And enveloping all these galaxies is an atmosphere of hot, shining gas that tells the deeper story of the cluster's temperature. Fact 42. A temperature map of the dark. When astronomers observe the Phoenix cluster in X-ray light, they can build a map of its temperature. A portrait painted not in color, but in gradients of heat. Some regions burn hotter, glowing fiercely with tens of millions of degrees. Others cool more quickly, forming pockets where gas condenses into colder streams. The map reveals the cluster's hidden structure, showing where energy flows, where cooling deepens, and where the black hole's influence stretches. These temperature variations trace the cluster's internal currents. Warm regions rise, cool regions fall, and together they form a slow, drifting circulation that fills the entire cluster. The effect is subtle, so gentle that it unfolds across millions of years. And at the center of this thermal tapestry lies an even larger force shaping everything: the cluster's vast halo of dark matter. Fact 43. A massive halo of dark matter. Beneath the Phoenix cluster's luminous galaxies and glowing gas lies something we cannot see: an enormous halo of dark matter. This invisible structure is far more massive than all the stars and plasma combined, shaping the cluster like a hidden bowl that holds every galaxy in its gentle gravitational curve. Dark matter does not shine or warm or radiate. It simply pulls, quietly, steadily, forming the deep well in which the cluster rests. Because of this unseen mass, galaxies orbit as if floating on the surface of a vast, invisible tide. Hot gas gathers in the lowest parts of the gravitational well, forming the glowing core where Phoenix A resides. Without dark matter's silent support, the cluster would drift apart long ago. And from this invisible scaffold, matter continues its slow fall toward the center of the cluster. Fact 44. Gravitational wells. Like basins, the gravity of the Phoenix cluster shapes space itself into gentle basins, curved regions where matter naturally settles. These wells are not sharp or steep. They are smooth and expansive, guiding galaxies and gas into long, graceful orbits around the core. Hot plasma collects within these basins like warm water in a bowl, slowly cooling as it radiates its light into the universe. As the gas cools, it flows inward toward the deepest part of the gravitational well, where Phoenix A sits. This inward drift is part of the cluster's long, meditative rhythm. Over millions of years, the motions remain steady and predictable, a calm circulation shaped by gravity alone. And along the edges of these vast basins, something new continually arrives from the cosmic darkness beyond. Fact 45. Streams of infalling galaxies. The Phoenix cluster is not a closed system. Far beyond its glowing core, new galaxies drift slowly inward, drawn by the immense pull of the cluster's mass. These galaxies move like quiet travelers entering a great city, their paths shaped by distant tides of gravity. Some bring their own small clouds of gas. Others arrive stripped and quiet, having lost their outer layers during the long journey. As they fall toward the cluster, their shapes may soften and stretch, touched by the tides of the dark matter halo. Over time, they settle into orbits among the cluster's other members, contributing their faint light to the collective glow. And with each new arrival, the cluster grows gradually larger, gathering material in silence, all of it slowly finding its place within Phoenix A's vast gravitational realm. Fact 46. Shocks from colliding clouds. Deep within the Phoenix cluster's glowing atmosphere, enormous clouds of hot gas sometimes meet and merge. When they collide, they create gentle shock fronts, not violent explosions, but soft compressions that ripple through the plasma like warm waves. These shocks raise the temperature slightly, smoothing out differences in density and helping the cluster maintain its quiet equilibrium. Even though the motions span millions of light years, the effects unfold slowly, like the settling of dust in a sunbeam. The shock fronts, seen in X-ray images as faint arcs or curves, reveal where the gas has been gently stirred by ancient movements or by the migrating influence of Phoenix A's energy. And after these clouds meet and settle, the core of the cluster settles back into its steady, luminous glow. Fact 47. The quiet central plateau. In the very heart of the Phoenix cluster lies a region astronomers call the Central Plateau, an area remarkably calm and uniform despite the ongoing cooling flows and black hole activity. Here, the temperature remains relatively stable, and the motions of gas slow into a kind of cosmic stillness. It is a serene environment where the balance between heating and cooling feels almost perfectly aligned. This plateau forms because the energy released by Phoenix A spreads gently outward, warming the gas just enough to prevent abrupt collapse. At the same time, the cooling flows are strong but smooth, guiding material inward like soft currents. The result is a quiet, flat landscape within the cluster's glowing sea, a still center within an active world. And from this tranquil region, the oldest and brightest galaxy shines with a soft, enduring light. Fact 48. A galaxy, frozen in light. The brightest cluster galaxy at Phoenix's center glows like a giant ember, its starlight softened by dust and filaments of cooling gas. Though alive with star formation, its overall shape is smooth and rounded, as if carved from a single piece of soft, luminous stone. The galaxy seems almost frozen in time, illuminated by both ancient stars and new ones born from the cooling flow. Its enormous size comes from billions of years of merging with smaller galaxies drifting inward from the cluster's outskirts. Each merger added layers of stars, building a central giant that now anchors the entire cluster. Today, it stands as a glowing cradle for Phoenix A, holding the black hole in its quiet heart. And beneath its radiant surface, cool gas continues its long descent toward the cluster's silent, waiting core. Fact 49. Cold gas rain. Deep within the Phoenix cluster, cool gas condenses into delicate clouds that slowly drift downward toward the central galaxy. This inward motion is often compared to rain, a quiet, patient descent through the warm glow of the intracluster medium. The clouds fall along long, graceful filaments, guided by gravity and shaped by magnetic fields that hold them in narrow, winding threads. As this rain reaches the inner regions, it feeds the star-forming nurseries hidden within the galaxy's heart. Each droplet of gas carries the potential to ignite future suns, drifting through the cluster like the softest snowfall. The process is slow, steady, and silent, unfolding across timescales far longer than any human era. And as this gentle rain continues, it brings fresh material ever closer to the waiting pull of Phoenix A. Fact 50. A web woven by gravity. The entire Phoenix cluster is stitched together by gravity, an invisible force weaving galaxies, gas, and dark matter into one immense structure. This cosmic web extends across millions of light years, binding everything in place with threads too subtle to see but too strong to break. Galaxies follow these gravitational pathways, like beads sliding along invisible strings, drifting steadily toward regions of deeper mass. Within this web, streams of gas move in long, slow arcs, shaped by the contours of the cluster's dark matter halo. The central galaxy sits at the deepest point in the weave, collecting material like a basin at the bottom of a valley. This structure is both delicate and powerful, a quiet architecture created by the universe's most fundamental force. And at the very bottom of this vast gravitational tapestry lies the warm glow of Phoenix A's inner realm. Fact 51. Seeing through X-ray eyes. To understand the Phoenix cluster, astronomers turn to telescopes that can see the universe in X-rays, a form of light far more energetic than anything our eyes can perceive. Instruments like the Chandra X-ray Observatory reveal the cluster not as a dark sky dotted with stars, but as a luminous, glowing cloud, rich with structure and motion. In these images, hot gas shines like a soft lantern, cavities appear as gentle dimples, and filaments stretch like faint wisps across the core. Through X-ray eyes, the subtle interplay of heating and cooling becomes visible. Warm regions glow more brightly, cool pockets form slender shadows, and the signatures of ancient outbursts whisper from the cluster's interior. It is a view of the cosmos not in color, but in temperature, a portrait of energy and motion painted across deep space. And through this glowing canvas, the story of Phoenix A becomes clearer with every passing observation. Fact 52. The glow of hot plasma. The Phoenix cluster shines in X-rays because its gas is heated to extraordinary temperatures, tens of millions of degrees, far hotter than the surface of any star. At this temperature, the atoms are stripped of their electrons, forming a shimmering plasma that fills the cluster like a radiant fog. This hot medium glows softly, its light traveling billions of years to reach our telescopes. Despite its extreme heat, the plasma is incredibly thin, far more rarefied than the emptiest vacuum a human could create on Earth. Each glowing atom is spaced across vast distances, drifting freely through the cluster's enormous volume. And yet, taken together, their quiet radiance paints the Phoenix cluster with a warm, ethereal brilliance. This glowing plasma is the canvas upon which Phoenix A writes its long, slow story. Fact 53. Infrared embers. While the X-rays reveal heat, another part of the spectrum shows warmth of a different kind. In infrared light, the central galaxy glows with the soft energy of dust warmed by newborn stars. These tiny grains of cosmic soot absorb the ultraviolet rays from young suns and re-emit them as gentle warmth, producing a glow that feels quieter and more intimate than the cluster's blazing X-ray light. Infrared maps reveal ribbons of dust winding through the galaxy's center, tracing the paths where star formation is most active. Some of this dust drifts in from the cooling filaments, while other grains form in the atmospheres of aging stars. Together, they create a subtle haze, a warm, velvety glow that softens the galaxy's bright interior. And woven into that warmth is the gentle signature of the stars that will light the future cluster. Fact 54. Radio waves, like soft murmurs. The Phoenix cluster also hums gently in radio wavelengths, where astronomers detect the faint traces of charged particles spiraling through the black hole's magnetic fields. These signals, quiet and understated, stretch across vast distances, carrying the memory of ancient jets and long-faded eruptions. Even when the black hole rests in a mild state, the radio glow persists like an echo lingering in the dark. These radio waves do not paint bold images. Instead, they reveal subtle shapes, the outlines of cavities, the drift of filaments, the ghostly wings of old outflows. They act as soft murmurs from the cluster's past, whispering of times when Phoenix A fed more vigorously. And through those murmurs, astronomers gain a deeper understanding of how energy gently moves through the cluster's glowing heart. Fact 55. A multicolored universe. To fully understand the Phoenix cluster, astronomers look at it through many kinds of light. Each wavelength reveals a different layer of its story. X-rays show the blazing heat of the plasma. Infrared glows with the warmth of new stars and dust. Radio waves whisper of ancient jets, and visible light captures the soft shine of hundreds of galaxies drifting through the cluster's embrace. Together, these wavelengths form a mosaic, a multicolored portrait of a single, unified structure. None of them alone can reveal the cluster's secrets, but when blended, they create a tapestry rich with meaning. Hot regions shimmer, cold filaments grow clearer, and the footprints of the black hole's activity come into view. Through this gentle spectrum, the Phoenix cluster's hidden complexity unfolds like a slow cosmic sunrise. And with each layer of color, we move closer to the fine details carried in its light. Fact 56. Measuring invisible motion. Even though the cluster appears serene, the gas within it moves constantly, drifting, cooling, flowing, and rising in currents too subtle for the eye. To trace these motions, astronomers study the spectrum of Phoenix's light, looking for tiny shifts in wavelength that reveal how fast gas travels along our line of sight. These spectral fingerprints behave like notes in a quiet melody, hinting at invisible movements through faint changes in color. A slight shift toward blue means gas is drifting gently toward us. A shift toward red means it's slipping away. By mapping these changes across the cluster, scientists build a picture of its internal circulation: slow waves, falling filaments, and warm flows rising like soft thermal breezes. And through these spectral whispers, the cluster's inner rhythm becomes clear, guiding us deeper into the heart of its luminous warmth. Fact 57. A cosmic furnace. The Phoenix cluster is one of the brightest X-ray sources in the known universe, glowing with the intensity of a cosmic furnace. This brilliance comes from its enormous reservoir of hot plasma, heated by both gravity and the long, steady influence of Phoenix A. As cooling and heating interact, the cluster radiates energy outward in every direction, sending a warm shimmer across millions of light years. Yet despite this strength, the furnace burns quietly. There are no sudden flares, no bursts of violent heat, just a calm, enduring glow that has persisted for billions of years. The balance of cooling flows and gentle black hole activity shapes this brightness, giving the cluster its rare combination of intensity and tranquility. And from within that glowing furnace, the light that reaches us today began its journey long before humanity's story even began. Fact 58. Light, delayed by distance. Every photon that reaches us from the Phoenix cluster carries a story that began billions of years ago. Its journey is unimaginably long, crossing the expanding fabric of space, slipping past galaxies, weaving through cosmic voids, and finally arriving at our telescopes. Because of this immense distance, we see the Phoenix cluster not as it is today, but as it looked 6 billion years in the past. This delayed light is like a gentle message from a younger universe, softer and slightly stretched by cosmic expansion. Colors shift toward red, details blur with distance, and every snapshot becomes a time capsule. Through this ancient glow, astronomers glimpse the cluster's youth, its warmth, and the quiet balance that shaped it so long ago. And through that softened light, we approach the hidden signals that reveal its vibrant starbirth. Fact 59. The dim pulse of starbirth. Amid the Phoenix cluster's bright X-ray glow, there exists a quieter signal: the faint pulse of star formation unfolding deep within the central galaxy. Newly forming stars emit ultraviolet light and soft infrared warmth, traces that drift outward like dim heartbeats lost within the surrounding blaze. These rhythms are subtle but resilient, carrying the signature of hundreds of new suns igniting each year. By observing these faint signals, astronomers can measure the cluster's remarkable star-forming activity. Dust absorbs the ultraviolet glow of young stars and re-radiates it in the infrared, painting a gentle, warm haze around the galaxy's core. Even buried beneath thick clouds of cooling gas, these stars still leave their imprint, a quiet chorus beneath the louder glow of hot plasma. And within that chorus lies the faint, steady glow of the black hole that shapes it all. Fact 60. A black hole's quiet glow. Phoenix. A itself emits no light, but the space around it radiates brilliantly. Gas swirling near the event horizon heats to extraordinary temperatures, forming an accretion disk that glows in X-rays and ultraviolet light. This glow is soft, yet powerful, shining across billions of light years to reveal the black hole's presence. It flickers gently as the flow of gas changes, creating a subtle pulse that mirrors the black hole's slow breathing. Even the jets emerging from Phoenix A contribute to this glow, warming the surrounding gas and creating gentle cavities visible in X-ray images. The black hole's glow is not a blaze, but a warm, ever-present lantern, illuminating the cluster's core with a steady radiance. And from this lantern of quiet light, we move toward the deeper story of how the cluster itself first came to be. Fact 61. Born from collisions. Long before the Phoenix cluster settled into its present calm, it was shaped by ancient collisions. Smaller clusters and groups of galaxies drifted toward one another over billions of years, guided by the pull of gravity. When they met, their hot gas blended, their dark matter halos merged, and their galaxies passed through each other like ghosts. There were no fireworks, no sudden bursts, just the slow folding of one structure into another. During these early mergers, shock fronts and gentle waves of heat rippled through the forming cluster. These motions stirred the gas, warming some pockets while allowing others to cool. The result was a young cluster full of motion, slowly settling into the shape we see today. And within this merging cradle, the seeds of the central galaxy and Phoenix A were quietly planted. Fact 62. A galaxy that grew by eating the brightest galaxy at the heart of the Phoenix cluster did not form all at once. It grew gradually by absorbing smaller galaxies that drifted in from the outskirts. Each time a new galaxy approached, it was stretched by gravity, pulled apart, and gently woven into the central giant. Over billions of years, these mergers built a massive, rounded galaxy filled with the blended light of countless stars. These interactions were not violent on human timescales. Rather, they unfolded slowly, like two clouds merging in a quiet sky. Stars from the smaller galaxies joined wide, sweeping orbits. Their gas settled into the core. Their light added new layers to the galaxy's soft glow. This gradual growth created a central galaxy vast enough to cradle Phoenix A comfortably in its depths. And as the galaxy grew, so too did the dark giant resting at its core. Fact 63. A black hole that fed for ages Phoenix A did not become enormous overnight. It grew through a long, patient process, consuming gas, dust, and perhaps even smaller black holes delivered during galaxy mergers. Each infalling stream added a tiny bit of mass, and over billions of years, those small contributions built a gravitational titan. Its growth was steady and quiet, more like a deepening well than an expanding fire. During periods when the central galaxy was especially rich in cold gas, Phoenix A brightened, feeding more vigorously and sending waves of heat through the cluster's core. In quieter eras, it rested, glowing softly, but influencing its surroundings all the same. These cycles shaped the cluster's history, carving cavities, stirring waves, and maintaining the delicate balance that defines Phoenix today. And from this long, slow nourishment, the black hole became one of the largest known in the universe. Fact 64. Cooling that never stopped. In many galaxy clusters, the gas eventually stabilizes, reaching a balance that slows or even halts cooling altogether. But in the Phoenix cluster, the cooling flows have persisted for billions of years, almost uninterrupted. The hot plasma gradually releases its heat, condensing into long, graceful filaments that drift inward like slow-moving rivers. This ongoing cooling is part of what makes Phoenix so unusual, a cluster where the past is still alive in the present. These cooling flows bring life to the core, nourishing both star formation and the steady feeding of Phoenix A. Instead of fading into stillness, the cluster continues to renew itself, with cool gas cycling inward and warm energy drifting outward in a gentle, continuous loop. And from this endless cycle comes the pattern of outbursts and quiets that shape the cluster's inner realm. Fact 65. Cycles of outburst and calm. Over cosmic time, Phoenix A has moved through long cycles of activity. Sometimes it feeds heavily, brightening the core and sending strong jets through the surrounding gas. During these eras, new cavities form, waves ripple outward, and the cluster's atmosphere warms. At other times, the black hole rests in a softer state, glowing gently, while cooling flows gather strength. These alternating periods create a rhythm that governs the cluster's evolution. Warm phases slow the cooling. Calm phases allow it to flourish, and together, they create the delicate balance we observe today. Although these cycles occur over millions of years, their effects remain etched into the cluster's structure in rising bubbles, fading ripples, and subtle gradients of heat. And within these patterns, we find signs of older outbursts captured in drifting, buoyant shapes. Fact 66. Giant bubbles rising like lanterns. Throughout the Phoenix cluster, astronomers have discovered enormous bubbles carved into the hot plasma by ancient jets from Phoenix A. These bubbles are vast, some larger than entire galaxies, and they rise slowly through the cluster like glowing lanterns carried by warm air. Their interiors contain lower density, warmer plasma, while their rims mark the gentle boundaries where the jets once pushed outward. As these bubbles drift away from the core, they stretch, soften, and eventually fade into the cluster's atmosphere. Their movement stirs the surrounding gas, helping distribute heat and maintain the cluster's fragile equilibrium. Even long after the jets that formed them have quieted, the bubbles remain as serene, floating monuments to the black hole's past power. And from the paths of these ancient lanterns, we learn how Phoenix A has shaped its environment over countless ages. Fact 67. The soft drift of rising bubbles. As the buoyant bubbles created by Phoenix A begin their slow ascent, they move with remarkable grace. The hot plasma inside them is lighter than the surrounding gas, allowing the bubbles to rise gently, as if carried by a cosmic breeze. Their journey upward can take tens of millions of years, unfolding at a pace so unhurried that even stars are born and die while a single bubble drifts through the cluster. These rising forms leave behind subtle trails, faint currents where gas flows around their edges, softening and smoothing the cluster's interior. They transport energy outward, mixing warm and cool regions with quiet persistence. And though their motion is almost imperceptible, the effects ripple through the cluster like the slow turning of a great cosmic tide. And as each bubble ascends, it reveals the long history of the black hole's gentle breath. Fact 68. Mixing the cosmic cauldron. While Phoenix Cluster's interior appears tranquil, the rising bubbles help stir it in delicate ways. As they move outward, they draw cooler gas upward in their wake and push warmer gas aside, creating soft circulation patterns throughout the cluster's heart. This mixing enriches the environment with elements forged in ancient stars: oxygen, iron, silicon, gently redistributing them across vast distances. These elements, carried by drifting currents, help seed new generations of stars. Over millions of years, the gentle stirring from bubbles and waves creates a shared cosmic soup, blending the products of past stellar lives throughout the cluster. Even in a place dominated by heat and gravity, the motions remain unhurried, like steam swirling slowly above a warm cup of tea. And within these mixed layers lies the hidden map of the cluster's long, evolving life. Fact 69. Turbulence, tamed by time. Although the Phoenix cluster undergoes cooling, heating, stirring, and waves of motion, its interior remains surprisingly calm. The expected turbulence, chaotic eddies, and violent swirling is far less pronounced here than in many other clusters. Instead, the motions appear smooth and coherent, as though time itself has softened every disruption into a gentle flow. Astronomers believe magnetic fields, buoyant bubbles, and the steady activity of Phoenix A help dampen the turbulence. The cluster settles into a peaceful equilibrium where gas moves in long, quiet streams rather than chaotic spirals. This unusual calm allows cooling flows to persist more easily, feeding the central galaxy and illuminating the core with new stars. And from this serene, ordered motion, the cluster preserves the delicate balance that defines its tranquil beauty. Fact 70. A symphony of temperatures. Within the Phoenix cluster, heat does not spread evenly. Instead, the cluster is arranged in a quiet symphony of temperatures. Warm regions glowing brightly in X-rays, cooler pockets darkening into gentle shadow, and transitional layers blending the two like soft shades of morning light. These temperature gradients reveal how gas moves, settles, and cools over millions of years. Hotter zones tend to rise slowly, drifting outward with light buoyancy. Colder streams sink toward the heart of the cluster, guided by gravity and shaped by magnetic fields. Together, these flows create a subtle circulation, each region influencing the next in a delicate chain of interactions. The result is a living environment that breathes warmth and coolness in slow, cosmic intervals. And through this layered landscape, the cluster's quiet rhythms continue their endless cycles. Fact 71. Shadows in the X-ray sea. When astronomers peer into Phoenix using X-ray telescopes, they sometimes find gentle shadows, dim patches where the glow weakens. These shadows are clues, marking the presence of cooler gas or cavities carved long ago by Phoenix A's energy. They resemble soft footprints pressed into a glowing surface, each one a sign of movement or change in the cluster's past. Some shadows outline the long, cold filaments drifting toward the core. Others trace the rims of ancient bubbles, now rising slowly toward the cluster's outskirts. Still others mark regions where gas has cooled into dense clouds, shielding X-ray light and casting gentle darkness across the glowing plasma. Each shadow tells a small part of the story, like a whisper from the cluster's memory. And behind every whisper lies a structure deeper and softer still, the Phoenix cluster's luminous heart. Fact 72. The luminous heart. At the center of the Phoenix cluster lies a heart made not of flesh or fire, but of light. The brightest cluster galaxy radiates a warm, diffuse glow, softened by dust and enriched by countless stars. Young, hot suns sparkle within it, while ancient, redder stars form a calm backdrop, a tapestry woven from billions of years of cosmic history. This heart is vast, extending over hundreds of thousands of light years. Filaments of cooling gas drift into it like quiet rivers, feeding new star birth. And deep within its glow, wrapped in layers of stars and dust, rests Phoenix A, the quiet giant whose presence shapes everything around it. From this luminous heart, the energy of the cluster flows outward and the cool material flows inward, creating a gentle balance written in light and warmth. And beyond this glowing center, the cluster stretches outward into its enormous, silent realm. Fact 73. The gentle gravity of galaxy motions. The galaxies within the Phoenix cluster do not rush or collide abruptly. Instead, they drift in long, slow arcs shaped by the cluster's immense gravitational pull. Their motions are graceful, like lanterns floating on a calm night sea. Each galaxy traces a path set millions of years ago, its orbit shaped by the dark matter halo surrounding the cluster. Even when two galaxies pass close to one another, the encounter is quiet. Their stars barely notice, sliding through without touching, guided by the delicate mathematics of gravity. Over time, these gentle motions reveal the underlying architecture of the cluster, a vast, invisible structure holding everything together in peaceful order. And within this serene ballet of galaxies, the glow of the central region shines like a beacon in the dark. Fact 74. The stillness between the stars. Though the Phoenix cluster is filled with hundreds of galaxies, most of its volume is empty space, calm, silent, and profound. The distances between galaxies are so immense that to travel from one to another would take millions of years, even at the speed of light. This emptiness may seem lonely, but it also creates a sense of cosmic stillness, a quiet backdrop against which the cluster's glowing structures shine more clearly. In this vast space, hot plasma drifts slowly, whispering in X-ray light. Tiny particles collide only occasionally, moving through an environment far more rarefied than any vacuum human machines have ever created. The silence here is absolute, broken only by the soft glow of atoms releasing energy into the dark. And across this tranquil expanse, the cool filaments falling toward the cluster's heart weave long, delicate threads. Fact 75. Filaments like cosmic waterfalls. The cooling filaments in the Phoenix cluster resemble waterfalls in slow motion, long, narrow streams of cold gas cascading toward the central galaxy. These structures stretch for tens of thousands of light years, shaped by gentle magnetic fields that guide their descent. Within them, gas condenses into dense pockets where stars may begin to form, hidden deep within the filament's shadowed interior. As the filaments fall inward, they twist slightly, curling like smoke drifting through still air. Their movement is slow, unfolding over tens of millions of years, yet their presence shapes the cluster's entire core. They bring fresh material to the central galaxy, replenishing the gas that fuels its star-forming glow and softly feeding Phoenix A. These cosmic waterfalls are among the most beautiful features in the cluster, quiet rivers of creation flowing through a warm, glowing sea. And from their gentle descent, the next chapters of the cluster's evolution continue to unfold. Fact 76. Stars born in the shadows. Deep within the filaments of the Phoenix cluster, new stars flicker into existence. They form quietly, hidden from the bright X-ray glow by thick blankets of cold gas and dust. These sheltered pockets act like cradles, protecting fragile newborn suns from the harsher environment surrounding them. Inside, gravity gathers the cool material until it collapses gently, igniting nuclear fusion and bringing forth a new point of light. These stars may be small or large, solitary or born in clusters, but all emerge from the shadows of the cooling flows. Their first light is soft, filtered through the dusty envelopes that surround them. Over time, they drift into clearer regions, adding their warm glow to the heart of the central galaxy. And each new star is a quiet testament to the cluster's enduring ability to create light from silence. Fact 77. Starlight woven with dust. As newborn stars emerge from the filaments, their light must pass through intricate clouds of dust. These grains, forged in the atmospheres of dying stars, scatter and soften the glow, giving the central galaxy its warm, amber tone. The dust drifts gently through the cluster's inner regions, following the currents carved by cooling flows and rising bubbles. When starlight shines through these dusty veils, it becomes diffused and dreamlike, spreading outward as a gentle haze. This warm cloud glows in infrared light, revealing elaborate shapes that mark the hidden paths of gas and filaments. The dust does not dim the galaxy's beauty. It enhances it, creating a soft radiance that makes the core feel calm and ancient. And beneath these veils of dust, the black hole's quiet influence continues to sculpt the inner galaxy. Fact 78. A core filled with quiet echoes. The central region of the Phoenix cluster carries the echoes of everything that has ever shaped it. Ancient mergers, cooling flows, long-faded jets, and the gentle heartbeat of Phoenix A. These echoes are not sounds but patterns, ripples in temperature, curves in the X-ray glow, faint shadows cast by drifting filaments. Every part of the core holds a memory of something that happened millions of years ago. Astronomers read these echoes like archaeologists studying layers of sediment. Each cavity marks an old outburst. Each temperature gradient hints at a past wave of heating. Each filament tells of long cycles of cooling. Together, they form a story written across light and time, patient and unhurried. And from these quiet traces, the cluster's deep past remains alive, guiding the flow of everything that happens today. Fact 79. The memory of mergers. Long ago, before the Phoenix cluster settled into its serene glow, smaller clusters drifted toward one another like slow-moving clouds. Their galaxies passed through each other. Their gas blended, and their dark matter halos merged in silence. Though the collisions happened billions of years ago, their signatures still linger. Faint shifts in temperature, subtle asymmetries in the X-ray light, and gentle gradients where the gas has not yet fully smoothed out. These remnants of ancient mergers behave like fossils buried beneath the cluster's modern calm. They reveal how the cluster grew from smaller pieces, each one leaving its imprint behind. Over cosmic time, these imprints softened, becoming part of the Phoenix cluster's tapestry of light. And woven into this tapestry is the steady influence of the black hole that anchors it all. Fact 80. Elements from ancient stars. The Phoenix cluster is rich with elements forged inside long-dead stars. When massive stars reached the ends of their lives, they scattered oxygen, iron, carbon, and silicon into the surrounding space. Over billions of years, these elements mixed into the hot gas that fills the cluster today, creating a chemical fingerprint that astronomers can read through X-ray spectroscopy. These elements drift freely through the plasma, carried by gentle currents, stirred by rising bubbles and cooling flows. Some settle into the filaments, helping form new stars. Others remain suspended in the cluster's warm atmosphere, glowing softly in high-energy light. Their presence reveals the long history of stellar birth and death that unfolded long before the cluster reached its current form. And inside the central galaxy, these ancient elements continue to spark new generations of stars, breathing quiet life into the cluster's core. Fact 81. The quiet clock of the cluster. The Phoenix cluster operates on timescales so vast that they feel like the ticking of a cosmic clock. Slow, steady, and almost unchanging from one human lifetime to the next. Cooling flows descend over tens of millions of years. Bubbles rise over hundreds of millions. The cluster evolves not in sudden leaps, but in gentle shifts, as if moving through time with a calm, measured breath. This slow pace brings a sense of stability. The core warms and cools in wide cycles. The black hole brightens and fades across epochs. Galaxies drift along orbits that will take billions of years to complete. The entire structure feels timeless, anchored by the quiet presence of Phoenix A at its heart. And through this unhurried rhythm, the cluster continues its soft, dreamlike journey through the universe. Fact 82. A cluster bathed in starlight. Although most of the Phoenix cluster's glow comes from its hot plasma, its galaxies contribute their own soft radiance, a faint blended starlight that fills the cluster like a shimmering mist. Each galaxy shines with billions of stars, their light overlapping across immense distances. From afar, the combined glow forms a delicate haze, gentle and diffuse, like moonlight seen through a thin veil of clouds. This starlight reveals the quieter parts of the cluster. It outlines the shapes of galaxies drifting in the outskirts and highlights the subtle arcs of faint gravitational distortions. Even in places where the hot plasma dims, the starlight continues to glow, offering a softer portrait of the cluster's sprawling form. And beneath that blended glow, the cluster's structure continues to deepen into layers shaped by gravity and time. Fact 83. The shape, carved by dark matter, the overall form of the Phoenix cluster, its roundness, its symmetry, its long, gentle edges, is carved by dark matter, the invisible substance that makes up most of its mass. Though we cannot see dark matter directly, we can sense its presence through the way galaxies move and the way light bends around it. These clues reveal a smooth, enormous halo, embracing the cluster like a soft gravitational cocoon. This dark matter halo guides the flow of gas, the orbits of galaxies, and the placement of the brightest cluster galaxy at the core. It shapes the cluster's evolution on every scale, from the path of a lone galaxy to the fall of a cooling filament. Without it, the structure would unravel. With it, everything holds together in a peaceful, enduring harmony. And within this invisible framework, the motions of the cluster unfold like a slow, cosmic waltz. Fact 84. Light bent into gentle arcs. One of the most beautiful features of massive clusters like Phoenix is gravitational lensing, the gentle bending of light as it passes through the cluster's immense mass. Distant galaxies behind Phoenix appear stretched into soft arcs, like brush strokes of light painted across the darkness. These arcs are faint and delicate, curving gracefully around the cluster's core. Though subtle, these distortions tell astronomers exactly how the cluster's mass is arranged. They reveal hidden pockets of dark matter, subtle variations in density, and the overall shape of the gravitational well. But beyond their scientific value, the arcs are simply beautiful. Quiet streaks of ancient light reshaped by the cluster's silent gravity. And through these softly curved echoes, the distant universe becomes part of Phoenix's serene portrait. Fact 85. The weight of an entire universe of light. The Phoenix cluster is so massive that it bends the path of light itself. Every photon passing near it feels the cluster's pull, drifting ever so slightly off course as it travels toward us. This effect, known as weak gravitational lensing, is subtle, too faint for the human eye, yet detectable when astronomers carefully map the shapes of distant galaxies. Their outlines become slightly stretched or tilted, whispering of the invisible mass between them and us. By studying these tiny distortions, scientists measure the true weight of the cluster, revealing a mass far greater than its visible stars and gas could explain. Most of it is dark matter, holding everything in place with silent strength. And with every bent ray of light, the universe quietly outlines the Phoenix cluster's immense presence. Fact 86. A cluster. Still growing. Even after billions of years, the Phoenix cluster is not a finished structure. Like a slowly beating heart, it continues to draw in new galaxies from the deep cosmic web. These galaxies approach from all directions, falling inward along filaments of dark matter that connect clusters across the universe. Their motion is patient and unhurried, taking hundreds of millions of years to complete the final descent. As each new galaxy joins the cluster, it adds its own light, dust, and stars to the Phoenix family. Some become part of the central region. Others settle into wide orbits along the outskirts. This slow growth reveals a universe in constant motion, where even the largest structures are never truly still. And every new arrival subtly reshapes the cluster's future, adding another quiet thread to its cosmic tapestry. Fact 87. The harmony of hot and cold. The Phoenix cluster's beauty lies in the gentle balance between extremes. Hot plasma fills most of its volume, glowing like a warm sea of X-ray light. Cold gas sinks quietly inward, forming filaments and clouds that nourish starbirth. Between these two realms lies a delicate transition zone, neither blazing hot nor deeply cold, where gas drifts in soft currents shaped by magnetic fields and gravity. This harmony allows the cluster to avoid instability. Hot gas rises, cool gas falls, and the motions merge into a slow, circular rhythm. It is a cosmic convection, unfolding across millions of years, maintaining the equilibrium that makes Phoenix so unusual. In this balance, the cluster becomes a place where heat and coolness, creation and stillness, light and darkness all exist together in peaceful coexistence. And in that gentle coexistence, the story of Phoenix A continues to unfold. Fact 88. Ripples through a quiet sea. Although the Phoenix cluster looks still, it carries faint ripples, gentle waves created by past outbursts from Phoenix A. These waves move outward through the hot plasma like rings spreading across a calm lake. They are subtle, almost invisible to the eye, but X-ray telescopes reveal their soft curves, stitched into the cluster's glowing interior. These ripples help distribute heat, smoothing temperature differences and preventing the cold gas from collapsing too quickly. They travel slowly, their motion stretched across millions of years, imprinting the cluster with patterns that last far longer than the events that created them. In their quiet persistence, they tell of cycles long past, and as each ripple fades, it leaves behind a slightly warmer, more balanced sea of gas. Fact 89. The soft drift of metals. The Phoenix cluster is filled with elements forged in ancient stars. Iron from supernovae, carbon from giant stars, oxygen from stellar winds. These elements drift through the hot plasma like fine dust suspended in warm air. Over time, rising bubbles and cooling flows mix them throughout the cluster, creating a gentle gradient of metallicity that reveals how often the cluster's gas has been stirred. The metals do not move quickly. They wander in slow, meandering paths, carried by subtle currents shaped by gravity and magnetic fields. Their presence enriches the cluster, allowing new stars to form with the raw elements needed for planets, atmospheres, and perhaps even life in distant galaxies. And with every drifting grain of metal, the cluster remembers the stars that lived and died long before our sun was born. Fact 90. Magnetic fields. Like invisible threads, within the Phoenix cluster, magnetic fields stretch across space like delicate, unseen threads. They guide the motion of charged particles, shape the cooling filaments, and help stabilize the hot plasma. Though we cannot see them directly, their influence is everywhere. In the way filaments stay narrow, in how bubbles rise smoothly, in the gentle suppression of turbulence throughout the cluster. These magnetic fields weave through the core like a subtle framework, holding the gas together while allowing it to flow in calm, coordinated patterns. Without them, the cluster's cooling filaments might tear apart, and the gas motions might become chaotic. Instead, the fields offer quiet support, a soft scaffolding maintaining the cluster's serene form. And through these invisible threads, the Phoenix cluster holds its structure, peaceful, balanced, and beautifully ordered. Fact 91. The slow dance of ionized gas. Inside the Phoenix cluster, most of the gas is ionized, stripped of its electrons by the intense heat. In this charged state, the plasma responds to every subtle influence: gravity, pressure, magnetic fields, even the faint pushes from rising bubbles. Instead of chaotic motion, the gas drifts in long, graceful flows, as though performing a slow cosmic dance choreographed over millions of years. These ionized particles weave through the cluster with steady purpose, carrying heat outward and guiding cooler material inward. They create smooth transitions between warm regions and cold filaments, softening the cluster's contrasts into delicate gradients. Their motion is not rushed. It feels patient, almost meditative. And through their quiet movement, the heartbeat of the cluster becomes visible, steady, calm, and endlessly flowing. Fact 92. Clouds that float for ages. Within the cooling flows are dense clouds of cold gas, some as large as small galaxies, yet tenuous enough to drift for millions of years without collapsing. These clouds float through the hot plasma like soft shapes suspended in warm mist. They cool steadily, radiating infrared light and slowly condensing into star-forming cores. The clouds are surprisingly resilient. Though surrounded by gas millions of degrees hotter, magnetic fields and gentle motions help shield them from being disrupted. Protected in this way, they can survive for ages, traveling inward along the filaments as though sliding down long, invisible rails. As they approach the center, they break into smaller fragments, each a cradle for future stars. And with every drifting cloud, the cluster renews itself, breathing quiet life into its glowing heart. Fact 93. A galaxy, nourished by the cluster. The central galaxy of the Phoenix cluster is unlike most brightest cluster galaxies, which tend to be old and dormant. Here, the galaxy is nourished by a steady stream of cool gas falling from the cluster's interior. This nourishment fuels a remarkable burst of star formation, giving the galaxy a youthful glow despite its ancient age. The infalling gas settles gently into the galaxy's halo, forming rings, wisps, and reservoirs that feed starbirth in the core. Over time, these new stars add fresh brilliance to the galaxy, blending with the softer light of older stellar generations. The result is a luminous, multi-layered glow, a living tapestry enriched by the cluster surrounding it. And at the galaxy's very center, wrapped in this soft radiance, the great black hole continues its slow, steady influence. Fact 94. Gentle currents in a cosmic sea. Though the Phoenix cluster is vast beyond imagination, its motions unfold with extraordinary gentleness. The hot plasma that fills most of its volume does not churn violently. Instead, it flows in soft, sweeping currents shaped by gravity and pressure. These currents drift around the rising bubbles, curve through magnetic channels, and wrap around the cool filaments descending toward the center. Each motion is delicate, stretched across millions of years. The cluster does not rush. It simply breathes. Warm gas lifting outward, cooler gas sinking inward, each responding to the other. These intertwined flows keep the cluster stable, like slow tides that never fully rest but never fully surge. And in these calm currents, the Phoenix cluster reveals its quiet, balanced nature. Fact 95. Echoes of distant galaxies. Beyond the glowing core, dozens of galaxies orbit slowly, each one a world of stars and dust in its own right. Their collective light forms a dim halo, scattered across the cluster, like faint lanterns drifting on a dark ocean. Some are spiral galaxies with blue, youthful stars. Others are old ellipticals, their light soft and reddish. Together, they form a chorus of ancient radiance surrounding the central region. Occasionally, the gentle pull of the cluster merges two galaxies into one, blending their stars and adding complexity to their shapes. These mergers happen silently, without the crashes we might imagine, because the stars are so far apart. Instead, the galaxies simply float through one another, their structures gently rearranged over millions of years, and each passing galaxy adds a quiet echo to the cluster's deep and layered history. Fact 96. A core that glows through every wavelength. The Phoenix cluster shines across nearly every form of light. Radio waves, infrared glow, visible light, ultraviolet shimmer, X-rays, and even faint gamma rays. Each wavelength reveals a different part of its story. Radio waves trace the ghostly bubbles rising from Phoenix A. Infrared light uncovers the cool filaments and the warmth of newborn stars. X-rays unveil the vast reservoir of hot gas filling the cluster. Seen together, these bands weave a complete tapestry, each color of light adding depth and texture to the portrait. The cluster becomes more than a glowing structure. It becomes a symphony of wavelengths, each humming its own gentle tune. Astronomers listen to all of them at once, stitching the signals into a calm, coherent understanding. And through every wavelength, from the softest radio hum to the brightest X-ray glow, the cluster's serene heart continues to shine. Fact 97. A universe still arriving. Even now, 6 billion years after its light first set out toward us, the Phoenix cluster continues to change. Slow streams of matter drift inward from the cosmic web. Thin filaments of gas, dark matter, and distant galaxies moving with patient inevitability. These arrivals happen so gradually that entire civilizations could rise and fall before a single galaxy completes its fall into the cluster's embrace. As these newcomers approach, their gravity tugs gently on the cluster's outskirts, reshaping the edges of its dark matter halo. Some galaxies will be stripped of their outer stars by the cluster's tidal forces, leaving only their quiet cores to settle into new orbits. Others will merge with neighbors, enriching the cluster with fresh starlight. And with each new arrival, the Phoenix cluster grows just a little brighter, a little larger, a little more complete. Fact 98. Traces of the cluster's first light. Although Phoenix is bright today, its earliest light was far more subtle. Faint glimmers from the first stars and galaxies that gathered in its infancy. Over billions of years, those ancient stars lived their full lives, releasing heavy elements into the growing pool of gas and dust. Their remnants now help fill the cluster with the metals needed to form new stars, binding past and present together in a quiet lineage of cosmic creation. Some of the oldest stars still shine in the outskirts of the cluster, their light soft and red, dimmed by age. They orbit the cluster's center like ancient guardians, carrying with them the memory of the universe's youth. Even though they are faint, their presence is a reminder that every bright moment began from something small and humble. And through these old stars, the earliest chapters of the Phoenix cluster continue to glow softly across time. Fact 99. A black hole that shapes a giant. At the very center of this enormous cluster rests Phoenix A, the supermassive black hole whose quiet breath influences everything around it. Though small compared to the cluster, its gravity and energy shape the entire core. Its jets carve out cavities, its heating slows the cooling flows, its presence guides the pace of star formation. Phoenix A is a conductor leading a cosmic orchestra, its influence subtle but transformative. Even in its calm state, the black hole radiates a steady, gentle glow through its accretion disk. This soft light, combined with the heat it releases, maintains the delicate balance between cool gas and warm plasma. Without Phoenix A, the cluster's heart would collapse into chaotic starburst. With it, the rhythm steadies into serene equilibrium. And from this central presence, the story of the Phoenix cluster flows outward like a calm, endless tide. Fact 100. A light that travels forever. The light from the Phoenix cluster has been traveling toward us for nearly 6 billion years, crossing vast oceans of space with quiet determination. Along the way, it has passed drifting galaxies, dark matter filaments, and clouds of intergalactic dust, never slowing, never fading in purpose. When it finally reaches Earth, that ancient light carries with it the entire history of the cluster. The cooling flows, the rising bubbles, the newborn stars, and the steady heartbeat of Phoenix A. To us, it appears as a soft glow in the depths of the sky. But within that glow lies a story still unfolding, a calm reminder that the universe moves at its own gentle pace. And as we look upon this distant giant, we glimpse a beauty shaped over unimaginable time. And in that distant light, the Phoenix cluster continues its quiet journey through the dark. And as our journey comes to a gentle close, I hope you found a bit of calm among the stars tonight. If you enjoyed drifting through these sleepy facts, don't forget to like the video, subscribe, and comment below what topic you'd love to fall asleep to next. When you're ready to keep dreaming, tap the end screen to watch the next Sleepy Astronaut video and continue your quiet voyage through the universe. Sweet dreams, and see you among the stars.